Hello students, welcome to NRMPU College online classes, and this is Setam Naidu Paila. I have been working as a chemistry senior lecturer in this institute for last 3 years. Okay. So now we will discuss one new chapter, that is chemical bonding and molecular structure. Clear? And the weightage of this chapter for the PU examination is 11 marks. So how many marks here? 11 marks. Okay. So 3 marks questions you will get 3 marks questions. 3 marks questions you will get 3, and 2 marks question 1. 2 marks question 1. Clear? So 2 marks question 1. Okay. So now 3 marks question 3 means total how many marks here? 9 marks, and 2 marks question 1, and here 2, and totally how many marks you will get? And 11 marks for the PU board examination. Clear? And also this chapter is very important for the competitive. So if you go for NEET or CET or mains, minimum 4 to 5 questions will come. Clear? So very important chapter, and also easy chapter, because some difficulty levels are there while going from first to last, and we will face some difficulty are there, and we will I will explain, no problem, everything. So here, and the total how many marks? 11 marks, and the total for competitive you will get 4 to 5. Okay? So this is about the weightage of the chapter. And now we will discuss, in this chapter we will discuss about the, if you see the heading of the chapter, what is this one? Chemical bonding and molecular structure. Clear? Chemical bonding means we will discuss in this chapter and different types of chemical bonds. Clear? We have, covalent bond, ionic bond, dative bond, and van der Waals forces. All we will study here in this chapter, and also molecular structure, and we will also study about the structure of the molecule, and means you can say simply geometry of the molecule, or you can say shape of the molecules. Clear? And now we will discuss some basic points here in this chapter, and after that we will go on by one. And you know that in this one, first of all, we have discussed molecular structures here. Molecular means, molecule. You have already studied atomic structure, and there atoms, about the molecules you have already studied. Clear? So you know that. What are the molecules? You know that molecules are, they are formed, group of atoms combined together and forms the molecule. Isn't it? Atoms means what? Atom is a very small unit of matter which is indivisible. Clear? So that's why atoms combined together and forms molecule. So you may get one doubt here, or one question. What is that? And molecules means atoms are combined together and producing molecules. Means, and there must be some force which holds these atoms together. Isn't it? So molecules means if you keep the molecule here and there, and molecule will not stay, will not come together, and they will stay there only, because atoms are there, atoms are in form of gaseous state. You have to bring those atoms, and they are coming and forming molecules, means there must be some attractive forces among the atoms, and that attractive forces we will call as a chemical bond. What that is? Atoms means, which state atoms are present. Atoms are present in the gaseous state, and they are coming and combining together, means there must be a force which holds the atoms together to form a molecule, and that attractive force and among the atoms in a molecule we will call as a, what it is here, chemical bond. So put the first one here. Chemical bond. What is chemical bond? Clear? Chemical bond. Yeah. So what is the definition of chemical bond? The attractive force the attractive force which holds the attractive force which holds various constituents. What are meant by constituents? Constituents means there can be, I have mentioned here atoms. There sometimes, you know, atoms, it can be R, it can be ions also. Constituents means what it is here? Constituents means atoms, R, what it is here? Ions, etc. Yeah. So here the attractive force which holds the various constituents together. Various constituents together in different chemical species. In different chemical species is called what it is here? Chemical bond. Is called chemical. So this is the definition of each one here. Chemical bond. Simple. What is the chemical bond means here? The atoms I mentioned. There must sometimes it may be ions also. Ions combine together and form a molecules. Atoms combine together and form a molecules. And there must be some force which holds these atoms and ions together to give the molecule. And that attractive force we will call as a what it is here? Chemical bond. Clear? So this is the definition of chemical bond. And now, and while we are studying about this, we have some questions. We can write some questions here. So I mentioned here atoms, they combine together and form a molecules. My question is here, why atoms combine? Clear? Why atoms should combine? And that is my first question. What is that one here? Why atoms? Why do atoms combine? Why do atoms combine? This is the first question. And if atoms combine, then which combinations takes place? Clear? Means why are and some combinations possible? Why are some combinations possible? Means, you know, I mentioned here combination. Why are some combinations only possible? Means just simple, I will say the one example. You already know that. Hydrogen, it is existed as a hydrogen molecule H2. Means what does it mean? One hydrogen and one hydrogen atom and another hydrogen atom, they combine and gives the hydrogen molecule. Can I write here hydrogen will combine gives the H3 molecule? Have you ever seen this type of formula? H3? No. We will write when we are writing the hydrogen atom means we will write the hydrogen molecule means we will write the H2. But we never write this. Means what does it mean here? Two hydrogen atoms combined and gives the H2, but three hydrogen atoms won't combine to give the H3. Why that is? That is the question. Why are some combinations only possible? Or you can say certain combinations are possible. Clear? So this is another question. And third one. Why are some atoms combined and why certain other atoms do not? Clear? Here another question. Why are some atoms combined? Why certain other atoms do not? This is also another question. Clear? See now? If I say simple example, I mentioned here hydrogen. One hydrogen atom, another hydrogen atom combined, and it gives which molecule? H2 molecule. And if I write here, helium atom and helium atom combines, it gives helium 2, it won't give. Means helium atoms will not combine to give the helium 2, but two hydrogen atoms combined to give the hydrogen atoms. Why this type of only some atoms combines, not all the atoms to combines? Some atoms only means you know hydrogen is there, chlorine is there, it will give Cl2. But you know helium it won't give helium 2. Why this type of some atoms only combined but other atoms won't combine? Okay, and fourth one is here. I will write here fourth one. Then fourth one and shape. Then why do molecules have definite shape? Why do molecules have? Why do molecules have definite shape? Why do molecules have definite shape? You know that different molecules have different shapes. Suppose if you take the ammonia means one nitrogen, three hydrogen atoms combined and gives the ammonia, and it has pyramidal shape. If you take CH4, methane, one carbon and four hydrogen combines and gives the CH4. Clear? So, and why these atoms, they are combining, but why they are combining in a different geometry? And that we have to study in this chapter. Then means what I want to tell here, first one, why atoms will combine to give a molecule? Why should atoms combine? And second one, you know that some combinations only possible, but not all combinations. What is the reason for that? That I have given. Two hydrogen atoms combined and gives the H2 molecule, but three hydrogen atoms combined, it won't give H3 molecule. Why these of some certain combinations are possible, not all? That we will study in the chemical bonding parts. Clear? And third one, why are certain atoms combined while certain other atoms do not? Suppose hydrogen and hydrogen combined, it gives the H2 molecule, but helium combined, it won't produce helium 2 molecule. Why this type of certain atoms only combined forms the molecule, not all? That also we have found out. And now when they are combining all molecules, why they don't have same shape? They have different molecules have different shapes, and these are the questions and answered by this chapter, that is chemical bonding and molecular state. To answer all the above questions, clear? And four different theories have been introduced, have been put forward by the time to explain all these doubts. And what are those theories? I will write first all the four theories and we will discuss one by one. So now what we have raised the questions, all those questions are answered by, and we have four different theories. And that is, one is Coastal-Lewis approach or theory, and the second one is valence. The second one is here valence shell electron pair repulsion theory. Clear? This we will call as VSPR theory. Yeah? And the third one is valence bond theory, can also be called as VBT theory. Yeah? And next one is molecular orbital theory and MOT, which is short form is what it is called here, MOT. Yeah. So these are the four theories, and which explains the and why atoms combines, and why certain combinations are possible, and why some atoms combined but not other certain other atoms, why molecules have different shapes. Clear? So we will discuss one by one about these four theories, and put the first heading here, Coastal-Lewis approach. Clear? So the first one is Coastal-Lewis approach. Clear? And this theory was introduced by and two scientists, and those are, one is what it is one here, Coastal, and another one is Lewis, in the year 1960. Clear? So it is introduced. This theory is introduced. This theory is introduced. This theory is introduced by and Cosel Lewis. Two scientist names, Cosel and Lewis. Cosel and Lewis in the year 1960. In the year what is what? 1960. Actually, and the number of attempts were made by the different scientists. Clear? So to give the exact formation of chemical bond, exact formation of what it is here, chemical bond in terms of electrons, in terms of what it is electrons, but and all the attempts were failed, and but here and Cosel and Lewis, they both are succeeded in giving a satisfactory explanation of formation of chemical bond. Clear? And this theory was based on the electronic concept of atom. Clear? So that is based on which one here? Electrons. Clear? And so that's why this theory can also be called as a electronic theory of valence. Electronic theory of what it is here? Valency. Because they have considered the valency electron of the atoms. Clear? So what is this? First I will explain, and after that I will write points one by one. Clear? This theory can also, because this theory is based on which one? Electrons, and how electrons forms the chemical bond. They have studied about that. Clear? And the next one, and this theory is can also be called as a electronic theory of valency. Valency means you already know that, you have studied already. Clear? So they have considered valency electrons to explain the chemical bond formation. Clear? So what are valency electrons? The electrons present in outermost energy level, those electrons we will call as a what it is here, valency electrons. You know that noble gases, you have already studied periodic classifications. So there you have already know about the noble gases. What are the noble gases now? So you know what is the electronic configuration of noble gases, and simply first I will write here helium. Helium, what is the atomic number? 2. So that's why this is 2. R we will simply write 1s2. And helium, neon atomic number how much? 10. 10 means we have written here 2 and 8 electrons. What does it mean? I will write here 1s2, 2s2, 2p6. This is 10 electrons. This is outermost cell. You see in this one, simple this is. See, this is the nucleus, this is the first cell, and this is the second cell. N is equal to 1, and here N is equal to 2. So in this is the outermost cell for the neon. So that's why how many electrons are there here? Inner cell, they have 2 electrons, and outermost cell 8 electrons. And these electrons we will call as a valence electrons. These electrons what we will call here? Valence electrons. If I take helium, neon, argon. Argon, how many electrons are there? 2, 8 and 8, because this is atomic number 18. Clear? So what we can write here? 1s2, 2s2, 2p6, 3s2, 3p6. Clear? This is inner cell, and it is also inner cell here. So that's why 2 electrons, 2 plus 2, 6, and here 8 electrons. Clear? If you keep on writing like this, helium, neon, argon, krypton. Krypton what we will write now? 2, 8, 18 and 8. Clear? What is the valency electrons here? This is outermost cell. Clear? So if you keep on writing this, if you observe except the helium, in remaining all cases, neon, argon, krypton, and if I write here xenon, 2, 8, 18, 18 and 8. Krypton if I write xenon and radon. Clear now? So what is the radon here? 2, 8, 18 and 32, 18 and 8. If you write like this, you will get it. So I will not write all these things. If you observe this, what are the valency electrons? And this is outermost shell electrons. How many are there? 8 electrons are there in the outermost shell. So that's why you know that it is a stable electronic configuration. If outermost electrons are 8, that valence electrons are 8, and that electronic configuration is a noble gas configuration, and you know that noble gas configuration is very stable. Why? Because if I write here 2s2, 2 electrons are there, and here s orbital and 3 electrons are there, means 6 electrons are there in the p orbital. Means what it is? These are fully filled orbital. You know that filled orbital or fully filled orbitals are very stable. Clear? So they have studied about, means they, I already mentioned, it is based on which one? Valence electrons. So they have considered here valence electrons of noble gases. Noble gases are, you know, chemically inert. They will not react in neither, you know, chemically other elements nor among themselves because of outermost electronic configuration, stable outermost electronic configuration. Clear? So that is the concept they have taken. Yeah. So means noble gases are inactive and, you know, very less reactive, inactive and more stable because of 8 electrons in their outermost shell are simply called as a valence, 8 valency electrons. Clear? And if you take, except the noble gases, remaining all are, you know, less than the 8 electrons in their valency shell. So that's why, and the remaining atoms are elements, you know, they are very reactive and less stable. Clear? So that's why atoms, they combined together to give a molecule. Why? Means to get the, what it is here, octet. 8 electrons are there, what we will call this is octet. Clear? To get the noble gas electronic configuration, atoms they combine. So the first answer, you know, first question, why do atoms combine, means one of the reason is this. Atoms are there, they never have the, you know, except noble gas, any atom they don't have 8 electrons on the outermost shell, less than 8 electrons only. So that's why they are very reactive, they combine to attain the 8 electrons on the in the outermost shell, or you simply say to attain the noble gas configuration. Clear? So that is the one of the main concept given by the question, and what it is here, Lewis approach, and that attain the, you know, 8 electrons in the valence shell, that we will consider as a octet. That rule this rule we will call as a octet rule. Clear? So this is basic concept they have taken. So I will write one by one points here. Clear? So now this is just explanation, it is not required. For understanding purpose, means except helium, and helium 2 electrons are there, it is also stable. That we will call as a duplet. 2 electrons are there, duplet. And remaining all noble gases, valence electrons, how many electrons are there? 8 electrons. So they are octet. In octet electronic configuration, they are stable. So that's why atoms combine to attain the octet in their valence shell. That is the reason why atoms combine each other to form a molecule. And how that, and we will discuss one later. Clear? So now, first this theory was introduced by Cosell and Lewis in the year, what it is not here? 6. And this is the first point. And this theory is, this is based on electronic concept of atom. Electronic concept of atom. Electronic concept of what it is not here? Atom. So that's why this theory can also be called as a electronic theory of valence. Electronic theory of what it is not here? Valence. So why atoms they combine here? That is we will write here. The atoms of different elements, combine together in order to in order to complete their respective octet. Their respective octet. Clear? Octet means what it is? 8 electrons, 8 valency electrons. That we will call as what it is here? Octet. Or sometimes what it is duplet. Duplet means what it is? Duplet. Okay? Duplet means what it is here? 2 electrons, like helium. In some cases only, that is hydrogen, lithium and beryllium. Some this elements only we will see that duplet. But mainly what it is here? Octet. Okay? And duplet is for only certain molecules. You can say those certain molecules are helium, lithium and beryllium. For those molecules only we will apply the duplet, and remaining all cases what it is here? Octet. 2-18 noble gas, 2-18 noble gas configuration. Noble gas configuration. Clear? And this is called octet fluid. And what we will call now this is? And this is called octet fluid. Very important this is. Okay, so this is the main points about the Quetzal-Lewis approach. Clear? So understand. I hope you understand about this why atoms will combine. So clear? So atoms are most of the means except the noble gases, remaining all will have the less number of octet electrons only. So that's why they are reactive and they try to gain the noble gas configuration by combining each other. Clear? So that is what is here theory of what is Quetzal and Lewis approach. And how they will attain the noble gas configuration. These atoms, while they are combining each other, how they attain the octet. Clear? So here atoms attain octet by 2 ways. By how many ways here? By 2 ways. That's the point. This is continuation only. By 2 ways. What are those ways? The first one here is transferring of electrons. First one what it is here? Transferring of electrons. And the second one is by sharing of electrons. Okay? What is that? I will take one example here, then you can easily understand. Clear? So first of all, by transfer of electrons. And due to this, you will get the ionic bond. We will discuss later completely what is about the ionic bond. Clear? And the next one, by sharing of electrons. Clear? And while electrons are shared among the atoms, you will get 2 types of bonds. One is covalent bond, or another one is what it is here? Dative bond. Or we can call it as a coordinate bond also. And we will discuss about the ionic, covalent and dative bonds separately. Okay? And in this way, atoms and what it is they attain the octet by 2 ways. Simple example I will say. I will take one simple example here, then you can easily understand. Okay? Suppose I will write here sodium. Clear? What is the sodium atomic configuration? 1s2, 2s2, 2p6, 3s1. Isn't it? So what is the atomic configuration of sodium? Sodium atomic configuration is 1s2, 2s2, 2p6 and 3s1. What is the here valence? How many valence electrons are there here? One only. This is outermost shell. This is inner shell. Clear? It is outermost shell. How many electrons are there here? Outermost shell. Only 1 electron. Means what can I write? 2 in the first shell, 2 electrons. Second cell 2 plus 6. This is 2 is there. Second shell. Second cell 8 electrons. Last cell, third cell 1 electron. How can I write this? Shall I write here? 2, 8, 1. This is the sodium. Clear? And this is sodium atom. Now I will write here chlorine atom. Chlorine atom you already know. Chlorine, how many electrons it will have? And 17, 2, 8, 7, 1s2. Same if you write like this: 1s2, 2s2, 2p6, 3s2, 3p5. This is 17 electrons total chlorine. See, 4 plus 6, 10 plus 7, 17. Clear? Shall I write? Here 2 electrons, and here I have 8 electrons in the second shell, in the third shell. These are valence electrons. How many are there? 7. Shall I write one in this way? This is 2 atoms are there in this way. So what they will do? They combine. Why? Why? Because you see, in this case, they are not having octet. Valence shell electrons how many? 1 only. Here valence shell electrons how many? 8. Got my point over here? So that's why they combine. They combine. How they combine? You see, what they will do? Sodium will give 1 electrons to chlorine. Sodium will give 1 electrons to which one? Chlorine. Then what will happen? You see here, when it is giving electron, means here it is transferring 1 electrons to which one? Here, chlorine. Then what will happen? You see, and here sodium now 2, 8. Previous how many are there? This 1 electron is there. It is now what is the valence shell electrons? Valence electrons how many are there? 8 valence electrons are there. 8 valence means what it is? They attain the octet or not? Yes, they attain the octet. So if you see chlorine, what happened? You see 2, 8. Previous how many are there? 7. But 1 electron is transferred here. 8. What is the valence electron here? This is last one is valence 8. Both you see by transferring the electron, both are getting what it is here. Both are attains the noble gas electron, means both are attaining the octet. Octet means what is valence electrons are 8. So it is losing electron. So losing electron means positive charge. 1 electron is losing, 1 positive. It is gaining 1 electron. Means this is the positive and negative. There will be attraction. This simply can be written as Na bond Cl. That is the chemical bond. This is bond. Attraction between the positive and negative charges, and that bond will be called as a attraction. That attraction will be called as a chemical bond. That chemical bond here is a ionic bond, because that is a bond is formed due to what is one? Transfer of electron. Transfer of electron means which bond you will form? You will get ionic bond. This is the, so how molecules means how atoms attain the octet by combining each other. So this is about the what it is here. So same, if I take another one example, simple example, I will take one chlorine and chlorine. Chlorine 2 and 7, 2, 8, or otherwise hydrogen. Hydrogen is having 1 electron here, another hydrogen is having what is 1 electron. They combine. When they combine, what they will give here? They combine here hydrogen and hydrogen. Now what is happening? You see, and if you see in this one, there are 2 electrons here. These 2 electrons are sharing. One is giving 1 electron, and another one is giving another electron. So that's why these 2 electrons are belongs to hydrogen, and these 2 electrons also belongs to which one? Hydrogen. So one hydrogen is having 1 electron, another hydrogen is having another electron. So they are not transferring here, they are sharing. I am giving 1 electron, you give 1 electron. So 2 electrons are there. One bond formation takes place. So that's why these 2 electrons now belongs to each hydrogen. So it attains which one? Doublet. It attains which one? Doublet. Doublet means it is stable. So that is the reason why atoms combine, means the atoms combine together in order to complete their respective octet or doublet to attain the noble gas. So next concept is here Lewis symbol. Clear? So Lewis symbol, and this was introduced by Lewis to denote the valence electrons in a atom. Clear? As I already mentioned, what are the valence electrons? The electrons which are present in outermost energy shell. These are cell nucleus. This is first shell, second shell, third shell, fourth shell. This means shells are there like this, and this is, you can say, outermost shell. The electrons present in this outermost shell we will call as valence electrons. Clear, means? So that is valence electrons. And here valence electrons are represented by, in this Lewis symbol, valence electrons are represented by dots which are kept around the symbol of atom. Around the symbol of atom. That is only the point here. See, valence electrons are represented by dots. How many valence electrons are there? And those many dots you have to put around the symbol of that atom. And that symbol we will call as a Lewis symbol. Clear? And this we will call as a Lewis symbol, or can also be called as electron dot symbol. I will write a few examples. Then what is this Lewis symbol? You can easily understand. And after that I will give you the table. Clear? Suppose I will write first of all lithium. I have to write the lithium Lewis. For the lithium, I have to write Lewis symbol. Clear? You know that lithium. Lithium, how many electrons are there here? Atomic number is 3. So atomic number means number of electrons. What is the electronic configuration? 1s2, and here 2s1. This is outermost shell. Got the point here? This is first cell and this is second cell. Electrons are present in the second cell. So that's why it is outermost shell. These are valence electrons. How many valence electrons are there with the lithium? One valence electron. So what is the symbol means? You have to write the first of all symbol of atom. What is that one? Lithium. Then how many valence electrons are there? 1. So that's why you have to put 1 dot here. Got my point here? Suppose if I write here boron. Boron means what is the atomic number? 5. 5 means how we will write electronic configuration? 1s2, 2s2 and 2p1. Clear? 2 plus 2, 4. And here, what it is here? 1. So totally, how many valence electrons are there here? Outermost how many? What is the outermost shell here? Second shell. In the second shell, how many electrons are there? 3 electrons are there. So that's why what is the symbol here means? Boron symbol, first we have to write boron. And then we have to write the valence electrons. How many valence electrons are there here? Don't write 5. Don't involve the inner electrons while writing the Lewis symbol. You have to write only outermost electrons. That is valence electrons. 3 valence electrons are there. Put here. There are 3 dots. That is the Lewis symbol. Suppose take like that. If you take the carbon, carbon means you know 6. 1s2 and 2s2 and 2p2. So how many valence electrons are there here? 4. So that's why first write the symbol and write here 4 electrons. Valence electrons are represented by 4 dots, and this we will call as a what it is here? Lewis structures or Lewis symbol. Then R we can call as a electron dot symbol. I will write here. I will draw one table. So first in this one, write here number of valence electrons. Number of valence electrons. Number of valence electrons. Clear? So next one here is example. And the next one is here Lewis symbol. The next one is Lewis symbol. Clear? So draw the table like this. Clear? The first one, number of valence electrons. Clear? Yes, symbol. So you know that, suppose if I write here number of valence electrons are 1. What are the example for number of valence electrons are 1? One is hydrogen. Hydrogen will have 1 electron. And also second one, first group elements, group 1 elements. Group 1 element. Group 1 element means what I have right now? Lithium, sodium. If I write first group elements, how many outermost electrons will be there? 1. So that's why first group element. So what is the symbol for this? Lewis symbol. For suppose hydrogen is there, 1 electron. Suppose if I take lithium, I have already written first group element only lithium, 1 electron. Sodium, 1 electron. Potassium, these all are belongs to which one? First group only. That is the Lewis symbol for the first group elements. Suppose if I write here 2 electrons. 2 electrons means what it is now? Helium will have 2 electrons, and also group 2 elements also have 2 valence electrons. Isn't it? Group 2 elements means what I can take here? Take the beryllium, magnesium, calcium. Beryllium means what it is, ma? 1s2, 2s2. How many valence electrons are there? 2. So that's why we can write here symbol helium. This is the 2 electrons. 2 electrons means should be represented by dots. And group 3 elements, if I take beryllium, here 2 electrons. Magnesium also belongs to, and calcium also belongs to second group only. And next one, if I write here valence electrons are 3. Valence electrons are 3. Valence electrons 3 means which group will have valence electrons 3? Group 3 elements will have valence electrons 3. Group 3 means what? 13th group. Clear? 13th group means what is? Boron, aluminium, those are. Boron, aluminium, gallium, indium and thallium. And those are group 3 elements. They will have how many valence electrons? 3 valence electrons. I have written first one here, boron. Boron belongs to which one, ma? Group 3 only. So that's why. What is the symbol to write here? Boron. If I write here aluminium, how many electrons are there here? Means valence electrons 3. Valence electrons are represented by which one? Dots. In the same way, fourth one means which group? Group 4. Group 4 means, carbon, silicon, germanium, tin and lead. So how many electrons? Carbon means how many valence electrons will be there? 4. Carbon, silicon. Silicon also how many electrons? Valence electrons are there? 4. Valence electrons are represented by dots. In the same way, 5. Clear? Valence electrons 5 means what it is, ma? Group 5th elements. Group 5th elements means what it is? Nitrogen, phosphorus, arsenic, antimony and bismuth. Nitrogen means 5 unbalanced electrons are there. So you have to write how many dots here? There will be a 5 dots. Nitrogen. In the same way, phosphorus. And in the same way, 6 group means 6 valence electrons are there. 6th group elements will have 6 valence electrons, because you know what is the 6th group elements outermost electronic configuration, NSP and P4. 2 plus 4, 6, that is clear, no? So group 6 means oxygen, sulfur, selenium, tellurium and polonium. So oxygen will have how many valence electrons are there? 6 valence electrons. You can keep like this, clear, no? Sulfur also. So 1, 2 and here also you can write anyway like this also. Clear, no? So this is next one. 7 valence electrons are there. Which elements will have 7 valence electrons? Group 7 elements will have. That is what is halogens. Fluorine, chlorine, bromine and iodine. If I write here fluorine and here these are the total how many electrons are there? 7. And if you take in this way 8 electrons are there. 8 electrons means what it is? Group 8. Group 8 means what is? Noble gases. Noble except what it is? Helium. Okay? So now if I take neon will have total how many electrons are there? Total 8 electrons. And this is the Lewis symbol for the what it is here? Molecule symbol. Clear? So not molecule here, simply atoms. Okay? So the next we will discuss, this is for the atoms, and we will also discuss the Lewis structures for the ions also. Clear? That will be discussed. So we have discussed the previous that table. The table is belongs to Lewis symbol of atoms. Previous what we have discussed, because I have not written any charges on the atoms, right? So that's why those are only simple Lewis symbol for simple atoms. Now we will discuss Lewis symbol of ions. For ions, what is the symbol? Clear? First of all, you must know when there is a bond. Suppose there is a bond between the two atoms. Clear? Bond is made up of how many electrons? 2 electrons, because one electron has to give one atom, another electron will give another atom, and by those 2 electrons will form one bond. Clear? So simply I will write here, one bond means how many electrons from here? 2 electrons. Clear? Now, if suppose just assume B is more electronegative than A. Electronegativity means what? Attraction of electrons towards it strongly. Clear? If B is more electronegative than A, then B what it will do? And it takes the electrons from A. A electron is there, that A electron is taken by which one? More electronegative atom. So A is losing electron, B is there gaining electron. Losing electron means acquires positive charge. Losing electron means acquires what it is much charge here? Positive. How many electrons it lose here? How many electrons it lost? How many electrons it lost? One electron. One electron lost means you know one positive charge. Suppose two electrons lost, two positive charge, 2 units of positive charge. Clear? So this A atom is, and it is one electron it lost, so that's why it acquires positive charge. It gained one electron, it acquires what is now negative charge. And remember that one, when electron lost, you will get the positive charge, and when electron gained, that atom will get negative charge. That you have to remember. Clear? So now in this one, charge on the ion. Suppose just assume here, take the any example. For suppose 1 plus I have written charge. 1 plus means what it is now? Atom lost 1 electron. So what it is now here? 1 electron lost. 1 electron lost. 1 electron lost. 1 electron lost means what it is now? Example, 1 valence electron. Which elements we have? I already mentioned the first one only table previous. Hydrogen will have 1 valence electron. Group 1 elements also have 1 valence electrons. So that's why here you will write the symbol hydrogen is there H plus because it lost 1 electron. And also group 1 elements, you know, group 1 elements also lost 1 electron. It can be, I have written simple, suppose lithium plus and what is known as sodium plus. So how to write the Lewis structure on this one? Clear? So now hydrogen plus it is there. Hydrogen plus means how many valence electrons are there with the hydrogen? No valence electrons, because you know this is only hydrogen means this is 1 valence electron, previous 1s1. Got my point over here? So that electron is lost. That electron is lost means there is no valence electrons for the hydrogen. So that's why how we will represent that. If valence electrons are there and it is represented by dot, there is no valence electron. So that's why we will simply represent it by and putting the symbol of element in the square brackets, and you have to write positive charge. Or otherwise simply you can write what is here H plus. That is the clear. So this is for lost 1 electron lost. Clear? So you know which elements here lost 1 electron here. That is clear. And next one 2 plus. 2 plus means how many electrons lost that element? That element lost 2 electrons. 2 electrons, you know, valence electrons 2. Which elements will have? Helium will have valence electrons how many? 2, but helium, you know, very stable electronic configuration, so that's why I will not write. And group 2 elements, shall I write here? Group 2 elements. Group 2 elements. They lose how many electrons? Plus 2. What are the group 2 elements? Beryllium. Beryllium actually what I have written symbol. This is the symbol. Now this beryllium lost 2 electrons means there is no valence electrons here. So that's why simply you have to write what it is now. Plus. Got my point here? So that's why this is plus 2. Or simply you can write here what it is now. Be plus 2. If it is magnesium, magnesium plus 2. And here 3 electrons lost. 3 plus means how many electrons lost here? 3 electrons lost. 3 electrons lost means what we can write here? We can write the group 3 elements. Group 3 elements we have already mentioned. Group 3 elements will have, you know, 3 valence electrons, and those all 3 valence electrons are lost. Then what we will write here? Boron I have taken. Boron. This is plus 3 because we previous what we have written. Boron is there. There are 3 electrons. Now boron lost how many electrons? All 3 valence electrons are lost by boron. There is no valence electrons for boron. So that's why we have to write here plus 3. Clear? Or simply what we can write here? Boron plus 3. Aluminium also you can write. If 4 lost, 4 plus means how many electrons lost here? 4 electron lost. Then what is the electrons here? Group 4 plus 4. What it is ma? Carbon. Same previous what I have written. That 4 valence electrons we have to remove. This is what it is here plus 4. And if I write here 4 minus means what it is here? 4 electrons gained. 4 electrons gained. Clear? 4 electrons gained means which one will gain the 4 electrons? to get the octet. Got my point here? Carbon group 4 elements will have how many valence electrons? I will take simple example here. Carbon. Carbon means group 4 element only. It is which element, man? Group 4 element. What is the electronic configuration? 1s2, 2s2, 2p2. How many electrons are there? 2, and here 4 electrons are there. To gain octet, how many electrons it has to gain? To attain the octet, how many electrons it has to gain? 4 electrons. 4 electrons if it gain, it become 8. Then it reaches what it is? Octet. Got my point now? That is only. Here, 4 electrons are gained by which group elements here? Group 4 elements. Group 4 elements. I am writing here over the 4 means group elements over the 4. Clear? So means what I have write here simple you see. You know that already how many electrons are there with the carbon? I already mentioned how many electrons are there. Valence electrons 4. And how many electrons it is gained? 4 electrons. So that's why this is the stage. If you try silicon also same. Right here silicon, clear, carbon, silicon, because they have these 14th group elements have 4 valence electrons. They can gain 4 electrons to attain the octet. If I write here 3 minus means what, man? Gaining 3 electrons. 3 electrons gain. 3 electrons. Which elements will gain the 3 electrons? Group 5. Because you know, group 5 elements will have 5 valence electrons. They can gain 3 more electrons to attain the octet. So that's why here, what we can write now here, group 5th elements can gain how many electrons? 3 electrons. So what is the symbol we can write here? Group 5 means what is it? Nitrogen. Nitrogen, phosphorus, arsenic, and 1. If I write nitrogen previous will have how many electrons? 5 electrons. Now it gained how many electrons? Valence 3 electrons, total how many? 8. So that's why this is the Lewis dot state. For which one here? This is 3 minus. Got me one? In the same way, 2 minus means what is it? 2 electrons gained. Means 2 electrons will gained by which group element? Group 6 element, because group 6 element will have 6 valence electrons. They will gain 2 electrons to attain the, what it is what? You know, noble gas. That is oxygen. Oxygen will have, this is the Lewis dot structure. Remember? Minus 2. And the last one is here, if it gain 1 electron, then what is 1 electron gained. 1 electron gained means which elements will gain 1 electron? Group 7. Group 7, how many valence electrons will be there? You know, that is fluorine, and here minus 1. So this is about the Lewis structures or Lewis symbols for the which one here? Ions. Simple. 1 electron loss means which elements will have 1 valence electrons, that is H plus and group 1. And here group 2 elements can lose 2 electrons, 3 electrons, 4 electrons, and group 4 elements can also gain 4 electrons to attain the octet. This is about the Lewis symbol of ions.